Homework 4.2, Logarithmic Functions, Video 4. Homework due Friday, May 29th at 11:59 p.m. The following homework problems are associated with this video. 9 through 18 and 25 through 32. That's a lot. Evaluating logarithms without a calculator, sort of. When we start evaluating logarithms, a natural question is, how do I put this in my calculator? Because my calculator has a log button, L-O-G, and a natural log button, L-N. So these last four we could put in a calculator, but all of these can be done without a calculator. And the reason I say sort of actually has to do with this problem. I'll explain what I mean in a moment. But yeah, every one of these can be answered without a calculator if you understand the question. And I know I sound like a broken record when I say this, but I say it over and over for a reason. The answer to a logarithm, if we want to write its full name, is the power that turns the base into the, rats are in a room, argument. If you can remember that, you can answer a lot of logarithms without the need for a calculator. For example, and we are going to go through all 10 of these. Let's take this one, log base 12 of 144. What is this asking? This is asking what power turns a 12 into 144. Now you probably know what that power is, because you probably know that 12 times 12 is 144, and 12 times 12 is the same as 12 squared. 2 is the power that turns 12 into 144, so 2 is the answer to log base 12 of 144. Again, if you know the question, sometimes the answer is easy. And sometimes it's not so easy, even if you know the question. What's the answer to log base 2 of 128? I don't know what the answer is, but I know what the answer does. The answer to this logarithm is the power that you would put on 2 that would turn it into 128. The problem is I don't know what that power is. So here's where the sort of part in the title comes. You have an exponent button on your calculator. You can just keep raising 2 to powers until you hit 128. And if you're lucky, you'll hit it. Don't worry, you will. Or you can take the 128 and start dividing 2's off of it. For example, 2 will go into 128 64 times. You could use a calculator if you wanted to. There's a 2. And honestly, you don't have to break off just 2's, but you're looking for 2's. Like 64, I could break into 2 times something, but I know 64 is 8 times 8. And each 8 is 2 times 4. There's a 2. But each 4 can be broken down into 2 times 2. Sorry if you're having trouble seeing these small 2's, especially if you're watching this on a phone. But eventually I could find out that it takes 1, 2, 3, 4, 5, 6, 7 2's multiplied to make 128. So when I say sort of without using a calculator, what I'm really saying is without just pushing a button to spit out the answer, but you can still use it to do things like, let me raise 2 to a power until I hit 128, or let me divide 128 by 2 until I see how many 2's it's made of. But regardless of your approach, 7 is the power that turns 2 into 128, which means 7 is the answer to log base 2 of 128. 7 as a power turns 2 into 128. What about the next one? Log base 2 of 1 over 16. Ew, a fraction. Well, you don't have to know what the answer is, but you need to know what the answer does. The answer to this logarithm is a power that turns 2 into 1 over 16. So what kind of power are you expecting? it looks like something got reciprocated. That means the power is negative. Now, you may or may not know what power of 2 is equal to 16, but using the same technique, you could figure out that it's 2 to the 4th power. So I could alternatively ask the question as, what power turns 2 into 1 over 2 to the 4th power? Well, a negative power equals the reciprocal of a positive power. And since the positive power here is 2 to the 4th, then the power over here was negative 4. Negative 4 is the power that turns 2 into 1 over 16. So negative 4 is the value of that logarithm. Log base 2 of 1 over 16 equals negative 4. Again, if you know the question and some exponent rules, some of these are easy. Like this one. What question is this asking? What power turns 6 into 1? There's an exponent rule that answers that for us. What power turns 6 into 1? According to one of our exponent rules, a 0 power will turn 6 and anything else into 1, except 0. So 0 is the power that turns 6 into 1, so log base 6 of 1 is equal to 0. This one's easier than it looks. Log base 8 of 8 to the 13th power. Now, I'm not expecting you to calculate 8 to the 13th power without a calculator. It's possible, it's just time consuming. But the question isn't what is 8 to the 13th power equal to. The question is, what power turns 8 into 8 to the 13th power? Did I not just answer my own question? What power do I put on 8 to make it look like this? That power? What power do I put on 8 to make it look like that? This power. This one's actually a lot easier because it answers itself. The power that you put on 8 to get 8 to the 13th power is 13. Didn't even have to figure anything out. I had to look and know the question. This one's a beast. That's not really a beast. It's just the trickiest one to rationalize, to figure out without just getting out a calculator. And even right now, getting out a calculator is no good because your calculator only has log, which is base 10, and ln, which is base e, and this is neither. But this one really hammers home the point that you don't need to know the answer to a logarithm, you just need to know what the answer does. So let's ignore this 7 for a second. And let's just focus on log base 7 of 5. I don't know what the answer to that is, but I know what the answer does. The answer to this logarithm is the power that turns 7 into 5. Let me say that again. The answer to this logarithm is the power that turns 7 into 5. Let me say it again. The thing under my hand, can you see that? The thing under my hand is the power that turns 7 into 5. Well, isn't this thing a power on a 7? And the thing under my hand is the power that turns 7 into 5. Guess what goes here? 5. What's the value of the log? Don't know, don't care. But I need to know what the log's answer does. The answer to this log, whatever it is, as a power turns 7 into 5. It's a power on a 7, and so by its own definition, it turns into a 5. That one's a little trickier to see clearly, but if you think about it, it must be 5. Not because of what this answer is, but because of what this answer does. These last 4 will be pretty straightforward. Log of 1,000. Oops, I didn't write a base. There's no oops to it, I did that on purpose. Remember, log without a base is called common logarithm, and what is its implied base? Base 10. So I could rewrite it as log base 10 of 1,000, It's a little unnecessary because without the 10 it means 10, but sometimes it helps to physically see the base. And what is the question being asked? What power turns 10 into 1,000? And it may be pretty evident. You can count the zeros. But 10 to the third power turns 10 into 3 turns 10 into 1,000 because 10 to the third power is 1,000, which means log of 1,000 is 3. This one you can put in your calculator because it has a log button. Don't believe me? Try it. Warning to those with one-line calculators, you must enter the argument before you press log. So 1,000 log is what you would press if you have a one-line calculator. What about the next one? Log base 10 of, excuse me, I didn't mean to say that. Log of 10 to the 19th. Well, just like the previous one, it is log base 10. And you don't have to write the base, but you have to know it's there. Now, you may be looking at this and think, I've seen this trick before. This is just like that one. Because the question here is what power would you put on 10 to get 10 to the 19th power? Well, the power I put on this to make it look like that is that power. You could put that in the calculator also. What about the natural log of e? Remember, ln is read natural log. It's in reverse because French. What is the implied base for natural log? The natural base. Natural log of e means log base e of e. Now think real hard about this one. What power would you put on e to equal e? What power would you put on something that leaves it the same? That power. 1 is the power you would put on the base to turn it into the argument. The reason I did this one is because down the road we will run into natural log of e by design, specifically because it's equal to 1. So get ready to hear that story again. And the last one, the natural log of the square root of e. Well, we know that natural log means log base e, and it's not necessary to write what I am writing right now. I'm only doing it to emphasize that natural log by definition means log base e. But what does the answer to this log do? The answer to this log is the power that you would put on e to turn it into the square root of e. Oh wait, we had an exponent rule for this. It had something to do with the index and the power. The implied power on this e is 1. Do you know the implied index when it's a square root? 2. So we had an exponent rule that said when we have things that look like this, we divide to get the exponent. Specifically, we divide this 1 by that 2. According to exponent rules, e to the 1/2 power is the square root of e to the first. Don't really need the 2 when you have a square root, and don't really need the 1 when you have a power. So 1/2 is the power that turns e into the square root of e, so 1/2 is the answer to this logarithm. You could also type these two in a calculator if you can press the buttons correctly. So in your homework, when it says evaluate a logarithm without a calculator, the majority of them are along the lines of what power turns the base into the argument, and for the most part, they're pretty easy to figure out, with the exceptions of one like this, where you may have a big number, but most of them are pretty straightforward.